Well, hello again, and this is week 10 of cis204 Unix shell scripting and utilities. And today we're going to talk about awk. Awk is a programming language, and in our preceding lectures we've talked about grep and the preceding lectures we've talked about grep and sed. grep being globally search for a regular expression in print, and sed being the streamlined editor. Um, grep, sed, and awk are three of the fundamental tools of Unix and Linux, and awk is probably the most powerful of the three, of course, but all three of these text processing tools are just really important to the whole Linux environment. And we'll spend some time dealing with awk, and your projects, in particular Project 5, will have you using awk scripting. So without further ado, and before I make any more funny faces, let me get rid of the cheesy camera. So awk. Awk is and the set of acronyms, or it's an acronym for Aho, Weinberger, and Kernighan. They wrote this process. And before we get very much further into this, let's do a quick review of week 9. Again, week 9 was the streamline editor. Sed processes a file one line at a time. Output of sed goes by default to standard out. Using the buffer for the current line of the file itself remains untouched. In other words, awk does not overwrite, sed does not overwrite the current line. It basically absorbs the current line from the file that's been supplied, the file name that's been supplied, and it will by default send the updated output to standard out. It does not update the file that it's reading from. So using the buffer for the current line of the file itself remains untouched. The line in the buffer is what's updated, and that buffer line is spit to standard out by default. Regular expression delimiter is user specified. It can be almost anything, but most of the time with sed you'll use the default delimiter, which is the slash. So normally sed will process all lines of the file. However, that's if you don't specify which lines to act on, or use some sort of the tools inside sed that will allow you to specify which lines to work on. But a restriction can be detailed, which will allow specific lines to be edited or specific lines to be ignored. So restrictions can be by a line number, a range of lines, which is two numbers separated by a comma, the end of the line, or the end of the file actually, or by a regular expression, or combinations of the above. And we saw that in the work we did in week 9. Sed employs meta characters like grep to support pattern searching. Word boundaries, not the regular POSIX expressions for uppercase, alphanumeric, that type of thing, or just the regular A-Z or capital A dash, capital Z inside square brackets. So all of that is available in sed. This is actually for a couple of terms ago's test. So regardless of the test, and this won't be on the test, it'd be good to know what the pieces of the string do. So sed substitute north for west globally and print. So what this is going to do is sed is going to substitute west for north anytime it occurs on the line, which is what the G is, and then it's going to print that output. So substitute west for north, do it anytime you see north in the file, and the file name is some file. So also the ampersand in the replacement string will copy what was found. So if I look for a sed and I want to search, I want to substitute two numbers. It could be 0 through 9, a number beginning 0 through 9, 0 through 9, and replace that with, and let me go to one of these terminals here, and we'll get to, let's see, that's not the one I want. Let's get this thing working here. So Control L, let's CD back a couple of, and we'll do outside, outside. Yep. Let's list here what we've got. So outside sources, CD to Quigley, CD to Splat 05. I think that's what we want. Is the data file there? More data file? Is this the data file we want? Boy, it assuredly is. Okay, so this long strung out thing here. So what will this do? Basically, it's going to look for two numbers. Any pattern that has two numbers at the end of the line, because that's what the $sign does here, at the end of the line, and it's going to put a .5 at the end of those two numbers. So let's look at this again. ls, or let me do this. More data file. So you can see there's a 34, a 23, an 18, a 15, a 17, a 20, a 13, a 9, and a 13 at the last field in the file. So now if I run that command, what am I going to end up with? Well, not a thing. And why not? Well, it looks like everything there should be fine. And let's see here. Sed, substitute. And it has to be at the end of the file. Let's try this again. That should have substituted 0 through 9, 0 through 9, ampersand, yep. Data file. Let's take a look at what we've got. Let's see what happens if we run this against datafile.save. There it is. Okay, so what I've got in front of me here, let me clear this off and we'll do this again. So as you see, what this did is it took the whatever the pattern was, the two numbers, and it appended a .5 at the end of it. But what did it do? What did the ampersand do? The ampersand basically took those two numbers and put them into a another buffer, and that buffer is then output with a .5 at the end of it. Also, we saw this, and this should work regardless of the end of the file issue that we've got. So what's going to happen? It is going to take this Margot and make that Marianne. How does it do that? Well, it looks for a string, Margot, but it also saves the first three characters of that string in a buffer labeled 1. It puts Marianne and then puts that into the buffer. So let's see what happens here. There it is. It kicked out Marianne Weber. Not Margot Weber, but Marianne Weber. And notice, it says don't print everything, but print the line that you updated. So that's how that works. Okay. A range of lines can be matched from a starting to an ending point. You can use line numbers or two expressions separated by a comma. Now here's the fun one. The -e option in sed allows multiple edits to occur on a line. So do this edit, then do this edit, then do this edit. The -e option, you put in one, you put in another. You can also read and insert a file into the output of sed. So you have, you're reading one file, you've got another file that you want to put into the output. That can be done. So lines processed by sed can be written into a file. So if I were looking for, in this case, north, I would write my file into the data based on what I'm reading from the data file. I can append place, which will place text below the current line, or I can insert, which places text above the current line. And the C command allows sed to modify text with new text. So that can be done. The next command causes sed to get the next line in the file. In other words, look for Eastern. Once you find that, go to the next line and then substitute Archie for AM. The transform, which is the Y command, is used to match something and transform it to something else. And you've used that, or you will be using that in your project 4. There's an additional buffer in sed known as the holding buffer. So a line can be sent to the holding buffer using the lowercase h or uppercase h command and retrieve from the holding buffer using the lowercase g or uppercase g for get command. Hold and g appends. H, the uppercase h and g will append. The lowercase hold and get copies. Or you can use the x for exchange. You can also invoke a sed script from the command line using the -f option. In other words, I want you to run the sed command, but what you need to run it is in this file, a -f option. So that can be done. So let's jump into awk. So in this machine, awk is in Ubuntu. So I did an ls-la on user bin gawk, and that shows me it's user bin gawk, and it's executable. It's owned by root. It's executable by everybody. So if I do an ls space -la user bin knock, that gives me etc alternatives knock. And if I do an ls-la user bin awk, that also gives me an etc alternatives awk. If I do an ls-la on etc alternatives knock, that points me back to user bin gawk. If I do an ls-la on etc alternatives awk, that turns out to be nothing more than a symbolic link back to user bin gawk. So regardless if I issue awk, knock, or gawk, it's all user bin gawk on Ubuntu. Whew. Okay, next. How about in CentOS? Well, it's pretty straightforward. If I type a which awk in CentOS, I get user bin awk. If I type which knock, it says there is no knock. If I type which gawk, I get user bin gawk. So let's do an ls-la on user bin awk. It too is the symbolic link back to gawk. So awk is gawk. awk is a UNIX programming language that's used for manipulating data and generating reports. Yeah, okay, that goes back to what we were talking about. Remember in the very beginning, when Ken Thompson needed a bigger machine to run space travel on, the dodge they used to get the machine approved was that UNIX could be used for text processing. Well, it all came, everything kind of grew from that. So you can manipulate data and generate reports using awk. Data can come from standard in or one or more files. So the command line, or it can be run on the command line, or you can embed it in the awk statements. You can embed them in shells. It scans files line by line to match patterns and, if requested, perform actions. Now, there's a wonderful statement about what awk is from Alfred Aho. Awk is a language for processing text files. A file is treated as a sequence of records, and by default, each line is a record. Each line is broken up into a sequence of fields, so we can think of the first word in a line as the first field, the second word as the second field, and so on. An awk program is a sequence of pattern action statements. Awk reads the input a line at a time. A line is scanned for each pattern in the program, and for each pattern that matches, the associated action is executed. So it's basically pattern action. So let's jump out of that, jump back into here. The awk views input stream as a collection of records which can be subdivided into fields. Remember, a line is the record. The line is composed of fields. A record is normally a line, with the familiar new line signaling the end of the record. Definitions of records and fields can be modified, and they can be modified while you're processing the records and fields. Awk uses patterns and actions to act on records and fields. Also, awk will allow you to handle multiple input files at a time. So what happens? Well, awk takes in a line and places it in a buffer, $0. So if I do awk print $1 employees or awk print $0 employees. So what's going on here? Well, let me take a look and see what we've got in this chapter. Do I have employees here? No. Let's get out of this and get back into this. And where's my employees? Not here. Let's cd ... and do 04 and see if I've got employees here. Nope. ... and let's do 06. Let's see 054 for grins. There it is. Okay, so let's try this. Print $1 in employees. So what do you think I'm going to get here? I'm going to get the first field. What happens if I do this? I get the first two fields. What happens if I do this? I get all of the fields on each line. The $0 is the buffer. That is the line in the buffer. So the next thing that is done is the line's broken up into fields, and the fields are numbered starting with $1. And there can be up to 100 fields. So that's something that you need to be aware of. Default field separator space is blank or white space, and that's something that you'll have to take into account when we start working with this. Again, all I've done here is I've asked awk to do an action. I want it to print the line that it reads, each line, $0, the whole line, all of the fields in the record. Remember, a record is a line in this case, and it does just that. If I look for a specific field, in this case, let me do $3. It gives me just that field. Okay. Let's move forward. Awk does not see input data as a string of characters, so it doesn't look at what the characters are, A to Z, digits or spaces, but it actually applies a format or structure to the input. So I'm not looking at individual characters, I'm looking at fields. It does this with an implied record separator, so it looks for fields based on white space and a line separator, by default a new line. So I know that I have fields with there's white space between them. I know that I have a complete record because there's a $sign at the end. Those are stored in awk variables, the output record separator, the record separator, and within specific limits, these values can be modified. So the field separator can be specified on the command line with the -f option. So I need to deal with the etc password file, which has a colon in it. The -f option, give it the -f, the field separator is colon. It works. So we're going to jump back into this in just a moment, but this is the first part, the end of part 1 of week 10 of cis204 Unix shell scripting and utilities, and today we're discussing awk.